Hello everyone, welcome back to part 2 of this video on solving a mixture problem with a differential equation. Just to recap from part 1, we worked with this equation right here, which was about this problem, which was about a solution of water with a salt in it, basically water and salt, coming into a tank. It flowed in at a rate of 5 gallons per minute, and every gallon had 2 pounds of salt in it. And at the same time, water would come out at 4 gallons per minute. And the tank held 500 gallons of fresh water. So first part of the video, we solved for the actual differential equation model. And what we're going to do today is we're going to go over finding parts, solving for parts B and C here. Now, last time we left off with this equation right here, which is dy dt equals 10 minus 4y over 500 plus t, with y of 0 is 10. So let me just do the amber color here and just circle that. So that's what we ended up with. And the first step in solving this equation is recognizing what type of equation it is. If you add the 4y divided by 500 plus t over, added on both sides, then it becomes what you see right here. And that is a first order linear equation, which is the form of what you have in purple. Now, I won't be going over on how you actually solve the equation. Don't get me wrong, I'm going to solve the equation right now, but I won't go into the why. I'm just going to solve it. Okay, I have a video on more into details of how to solve first order linear equations in the channel, so I'll look for that. But let's go ahead and get started on solving this. So what we're going to do is we're solving the first order linear equation. We're going to find our mu, which is e to the integral of whatever's in front of the y. So it's 4 divided by 500 plus t, excuse me. And if you integrated that, you get e to the 4 ln of the absolute value of 500 plus t. And I'm going to go ahead and put the 4 up as an exponent. And the e and the ln just cancel each other out. So you get 500 plus t to the 4th. And we're going to go ahead and take that mu and multiply everything in our differential equation by it. So you get 500 plus t to the 4th dy dt plus, and then when you multiply that second term, when I'm talking about that second term, this one by that, this would become 4 times 500 plus t to the 3rd y equals, and then last but not least the other side, 10 times 500 plus t to the 4th there. Okay. All right. So we have our mu multiplied, and the left-hand side, that is always equal to saying the product of y times mu and the derivative of all that. So that whole left side turned into y times 500 plus t to the 4th prime. Derivative equals 10, 500 plus t to the 4th power. Okay. So what we're going to do is we're going to integrate both sides. So you have y equals 500 plus t to the 4th. You integrate the other side, and this would come out to be 2 times 500 plus t to the 5th power plus c. And we can go ahead and solve for y. Y would equal 2 times 500 plus t to the 1st plus c over 500 plus t to the 4th power. So that is it. That's a general solution. Describe all the solved at any time. But we were given the condition that y of 0 equals 0 here. We were told that at the beginning you had 500 gallons of fresh water, so no salt was in there. So if we use that condition, you have 0 equals 2 times 500 plus c over 500 to the 4th. I'll move the 2 times 500 over, and you might not say, why don't you write it out as 1,000? I'll explain why in a second. C would equal minus 2 times 500 to the 5th power. Okay. And the reason I kept it as 2 times 500 was because when I realized we're gonna multiply by 500 to the fourth, you could use properties of exponents to simplify that, so that's how we came out with that. All right, so your equation here would be y equals 2 times 500 plus t minus 2 times 500 to the fifth over 500 plus t to the fourth. And that's what part B would look like. Not nice, but typically they don't look too nice either, these equations. And we had another question here, which was part C, which was asking for the amount of salt when at time 45 minutes. And for that, simply what you would do is, what I have written here, you would put in 5 in for your t, in for that equation. And this is the expression you get. And yeah, that's the exact expression, and it's correct and all. However, if you're looking for something a little neater, well, not neater, but if you want a decimal approximation to it, you can plug this into your calculator, and you get 381.57 pounds, approximately. That's what I got. So please take note of that. All right, well, I hope this helped. Thank you for your time.